So when you look at this architecture of a transformer network, you might be you might be scared, but I want to give this as comfort. What we had discussed in the previous chapter, the attention network, I would say that is the most complicated part of a transformer network. What we're going to do in this chapter, I believe it's quite straightforward. They will be straightforward, much easier. Even though these models are extremely good, they are trying to do what? To do next word prediction. So here maybe I should have said for our output layer, what this output layer would then write something like effort, every effort moves you, and it will predict this next word forward, right? That's what it will predict, this next word forward. They these models, they are much less complicated than you may think. Many of the stuff that we discuss in this chapter, they are just repeated many times. Like I said, some models we have 24 transformer blocks, some 96 transformer blocks. They just repeat the blocks. So now, what we are also going to change in this chapter is we are going to, for embedding layer, we are going to increase the number of dimensions for our embedding layer, because now I think we understand. We've been using the 3 dimensions and all of that for explanations, but I think now we understand. We are going to increase also the number of parameters. We're working with a very small models, but here they will be using will be working to aim for the smallest GPT-2 model, which is around 124 million parameters. 124 million parameters. But this can be scaled up to the medium, large GPT-2 models, which have 345, 762, and 1.5 billion parameters. The even GPT-3 itself, it is fundamentally using the same architecture that we are going to discuss in this chapter. It has just been scaled up to 175 billion parameters. But again, this architecture that we are going to discuss in these 7 steps, they apply. So let's go to code and see us now build. We said we're going to build the backbone. So let's build the GPT backbone. So let me just quickly switch my screen. Again, just loading our loading our packages that we're going to use. And here we are going to use this dictionary as our configuration. As you can see, this is the configuration for a 124 million um, parameter GPT-2 model. We're going to use a vocab size of 50,257 words. That's going to be our vocabulary size. When we were doing previously, we were just using maybe 6 words or whatever it is as our vocabulary size. That was just for explanation. But now we want to use a proper vocabulary size, 50,000. A context length, we were using 6 input tokens previously, but now we want to use a context length of 1024 as our context length. So that is going to be our input. So our input will be 1024 tokens as our input. Embedding dimension of 768 instead of the 3. Number of heads, we are going to have 12 instead of the 2. I think the previous chapter we used 2, but here we just use 12. Number of layers, these are going to be repeated, which is 12. And then our dropout, like we had our dropout 0.1. I think previously we had 0.5, but that's just our dropout there. And our bias, we're not going to include the bias here, we just put the false. So that's just it. So that is our configuration. So now when building our dummy model or our backbone, we're going to just initialize, and we've already discussed many of these parts. As you can see, embedding, we're just going to get there from our neural network module. We're going to get the embedding, and of what size? It's going to, this is the vocabulary size, and this is the embedding dimension. So here it will be 50,000, there's 50,257, and our embedding size will be 720, 768. So what will happen is when we get our token, we'll do the lookup. Where is that token? And we will get the embedding. We would convert that token into 768 dimensions or a vector of that size, 768. That's what this is supposed to do. We can go back to, I think it was chapter 2, where we discussed token embeddings. Pretty much that. And then here we just have the positional embeddings. Same size as this, because we are going to add the positional embeddings to the token embeddings. We have already discussed those. We are going to create our dropout according to the dropout rate. That's it. So this is just a dummy. This is a placeholder for our transformer block. Remember in the previous video, we showed that transformer block that's going to have our multi-head attention. It's going to have our GALU. It's going to have our shortcuts and all of that. We'll see that as we go. We'll see that as we go. And then our final, there's going to be normalization. So this normalization, we'll discuss normalization later. And then we have our our output layers. We did discuss we're going to have output layers, and the output layers are going to take the embedding dimension and they are going to get the vocabulary size. So they convert whatever comes out of the output, convert those numbers back into words. That's what it's supposed to do here. And then it outputs stuff. So now that we have initialized this, here we're now just creating our forward model. It just shows our forward model is how the data is going to move into the model itself through the model. So first we get our batch size and our sequence length. Then we have our embeddings. We apply our embeddings. We get our positional embeddings, and we say for that X, let's convert the X that comes in token embeddings plus positional embeddings. That's it. Then we apply our dropout for the embeddings. Then we apply our TRF blocks, which we are going to code. We're going to make it better. Right now, it's just dummy. Right now, really doesn't do anything much. And then we apply our final normalization, and then we spit out our logits. As you remember, at the end in the output layer, it spits out logits which can be converted now to probabilities using something like a softmax or whichever one you prefer. We're going to we have our logits. Our logits. Then we'll say, okay, which one is the most probable word that comes out? It's going to be forward and stuff. So that's pretty much what we're doing here. So this is just a backbone. As you can see, there's really nothing much there. Here, our forward just returns. Right now, it does nothing. It just returns the X, and we'll fill it in as we go. So here, when we have two, so you have two texts. You have every effort moves you. That is the first text, and then you have a second text. Every day holds a. You add to our batch, so which means we have a batch size 2 because we have two texts. We have two texts each with 4 tokens each. So here we just add our batch. That's we converted them into, we tokenized them, tokenized the text. So these are the tokenized texts, right? Tokenized texts. Perfect. We are using the GPT to tokenize them. Yeah, that's what we're using, right? So these have been tokenized. Perfect. And after tokenization, as it moves into the model, right? It gets tokenized, it gets embedded, and then moves up. So here we're now just going to put our batch. We've created our model as the dummy GPT model using our configuration. So it is instantiated in an object of this class here that we have just discussed. Brilliant. Nothing complicated at all. Nothing complicated at all. And then we'll apply that model. Right now, the model doesn't do much, but yeah, we apply the model on the batch. So it would get these, it'll embed them, it'll get positional embeddings. It's going to do all that stuff that we've put up there. And then it spits out the logits. Using these logits, then we'll say, okay, for this, for this, for this input, these are the logits. These are the logits, right? For that input, and then for the second batch, for the second input in the batch, it's gonna be these. These are the logits. Pretty much that's all we did. We are not doing anything much. We have a batch size of 2 when you look at the shape, right? Because we had a batch size of 2 each. with 4 tokens as input. And of course, it's going to be 50,000 is because that is our vocabulary size. So with that, then we'll do some lookups and all. But we'll see all this. Let's see in the next video. Because right now, what we just wanted to do was to create this backbone that we are going to build on top of, replace some stuff, and we see it actually come alive. We see it come alive. So let us see that in the next video when we move on to actually now start discussing the other parts of this transformer block.